Hi everyone, in this video we'll solve example 8.2 from the book Fluid Mechanics, Essential 3rd editions. Here is the statement of the example 8.2. Water at 40 Fahrenheit, its density is 62.42 pound per foot cube and dynamic viscosity is 1.038 multiplied by 10 to the power minus 3 pound per foot second, is flowing steadily through a 0.12 inch. Means to convert into foot it will be 0.01 foot diameters, and the pipe is 30 foot long and it is horizontals, and average velocity is flowing inside it, that is 3 foot per second. We need to find the head loss, pressure drop, and the pumping power required to overcome the pressure drop. So first of all, at 40 Fahrenheit, the densities of the water, that is 62.42 pound per foot cube, and its dynamic viscosity, that is 1.038 multiplied by 10 to the power minus 3 pound per foot second. The dia is 0.12 inch. Convert into feet, divide with 12 because 1 foot have 12 inch, then it will be equal to 0.01 foot. And the length of the pipe, that is L, and it is 30 foot. The average velocity of water flowing in the pipe, that is 3, that is foot per second. We need to find the head loss. First is to find the head loss, then B, it is pressure drop, and then third one we need to find the work input required in order to run the pump. Okay, so first we need to find the Reynolds number, and it is equal to rho Vd divided by dynamic viscosity. So what is rho? That is 62.42, average velocity is 3, diameter is 0.01, divided by dynamic viscosity, it is 1.038 multiplied 10 to the power minus 3. So after solving you will get the Reynolds number, that is 1803, which is less than 2300. So it means that the flow inside this pipe is laminar. So when the flow is laminar, then the fractions coefficient is 64 divided by Reynolds number. So 64 divided by 1803, you will get the fraction loss, that is 0.0355. Next is to find the head loss. So the head loss, that is our first requirement, is equal to FLV square divided by 2GD. What is head loss? Then it will be equal to what is fraction, coefficient of fractions, that is 0.0355 multiplied by length, that is 30 feet, multiplied by velocity, that is 3 square, divided by 2 multiplied by g, that is 9 point, sorry. So the g value in foot per second square is equal to 32.2 foot per second square, and it is constant. That must be remembers to you when you are solving problem in the exams. So here I can write in terms of g, that is 32.2 multiplied by dia, that is 0.01. So after solving this, you will get the head loss, that is for 14.9 foot almost. Next is to find the pressure. So pressure drop will be equal to the densities of the water multiplied by the head loss. So what is pressure loss? Then equal to densities of the water, that is 62.42 multiply with head loss, that is 14.9. You will get in terms of pound force per foot square, and its value will be 930 pound force per feet square. You need to find this 930 pound force per foot square into SI. Then we need to divide this 930 with 144, so it will be convert that into PSI, and it will be 6.45 PSI. PSI means pound per square inch. So the third requirement is to find the work input in order to run the pump. So for that we need to find first the volume flow rate. Volume flow rate is equal to average velocity multiplied by area of the pipe. So V multiplied by pi by 4 d square. So what is V? It is 3 multiplied by pi by 4. What is dia? That is 0.01 square. So after solving you will get the volume flow rate, and it will be equal to 0.0000236 foot cube per second. So finally the work input in order to run the pump is equal to the volume flow rate and the pressure drop. So what is volume flow rate? It is 0.00236 multiplied with the pressure loss, that is 930. So you will get it in terms of pound force foot per second, that is 0.21948 pound force foot per second. To convert that in terms of SI unit, we need to divide this terms with 0.737 to convert it into watt. So the work input in order to run the pump, that is equal to 0.297 watt. And that is our final answers of this example 8.2. I hope you understand. If you still have any confusion, you can ask in the comment sections. If you haven't subscribed my channel yet, please subscribe. Thank you so much.